The history of e. Arguably one of the most crucial constants in mathematics, e, or Euler's number, describes an irrational number used as the base of the natural logarithms. But before its discovery, e was unknowingly being used for decades in logarithmic equations. In 1618, Scottish scholar John Napier's published work on logarithms saw the first introduction of e within its appendix, likely written by mathematician William Oughtred. However, the constant was not explicitly stated and remained unnoticed in the shadows. 1647 saw Gregory of St. Vincent's computations of area under a rectangular hyperbola. This was used by Dutch mathematician Christian Huygens in 1661, when noticing a relationship between the area and the logarithm, and later when defining the exponential curve. Despite these discoveries, e was not explicitly noticed until 1683 by Swiss mathematician Jacob Bernoulli, when looking at problems of compound interest. Bernoulli attempted to find the limit of 1 plus 1 over n to the power of n as n tends to infinity, and found it existed between 2 and 3. 1 year later, the first connection between logarithms and exponents was finally made by Scottish scientist and professor of mathematics James Gregory. Another 60 years passed before German mathematician Gottfried Leibniz finally recognized the number independently, using the notation b. Sometime following, Bernoulli's younger brother Johann published works on the calculus of exponential functions in 1697. Whew, so now we have e, right? Well, not exactly. These early workings retrospectively became part of the understanding of e, but it was not really fleshed out until one Leonhard Euler arrived on the scene. Another Swiss mathematician, Euler denoted e as it is known today with a letter in 1731. Arguments have been made as to why it was denoted as e. Whether for exponential or Euler's last name, the notation remains unclear. Regardless, 1748 saw the spotlight finally on e through Euler's publication. In such, he showed e as a series and gave an approximation for such to 18 decimal places. Euler's work was groundbreaking, and it made connections between the sine, cosine, and the exponential functions, and demonstrated e as an irrational number. While the passion for determining more digits of e did not take off as famously as that of pi, mathematicians such as Sheikh and Glaisher demonstrated a passion with equating e to 205 places. After a century of discovery, e makes all tribulations worthwhile, as notably one of the most useful constants in mathematics. When graphing the function y equals e to the power of x, the slope of the curve remains as the original function, while the area under which from negative infinity to x is also e to the power of x. Sine waves, light waves, and quantum waves all use e, making it crucial in studies of physics. It is related to growth and change, and unlike many other numbers, it is not based on geometry, which is why it was discovered so recently compared to that of the geometrical constants. Mathematics today, such as calculus, would not be as developed without e, as it allows for simpler solutions, reducing ridiculously long equations. It is largely famous for its unionizing of all other notable mathematical constants through the formula e to the power of I pi plus 1 equals 0. Frankly, without e, the world of mathematics simply would not be the same.